Standard deviation. Standard deviation formula is, this is the standard deviation formula. This one, this is standard deviation formula. So it is summation fi into xi minus x bar. X bar is the mean of the data, xi is the mid value of the class. Then square it, then multiply by fi, and then take the sum. This is summation fi, this one, then divide by total number of frequency, and take the square root, and this is the standard deviation. And when it is not grouped, we consider all values individually. In that case, fi is always 1, so our formula is this one. And like in case of average, we did it. We consider one assumed mean a, then took the deviation of this mid values from this xi from a. This is di, and this is the formula for this. And step deviation method is we divide this d by the length of classes. So these are the three formula for standard deviation. Now here, so mean and standard deviation of the following data. So mean, we know, you consider this, this is not group data, this is ungrouped data, number a. So it is 25 plus 34 plus 31, etc. So you add all this, then divide by 7, 10, divide by 15. N is 15 here, so n is 15, so divide by 15. Then consider the summation xi, I varies from 1 to 15, then divide, so you are getting x bar. X bar is summation xi divided by 15. This is your x bar. Then you need to find, so these are xi, so to find standard deviation, we take one column xi minus x bar. So this column you make, suppose our this 25 minus x bar, you get the value here. So 25 minus x bar, then it is we have some value here, then 34 minus x bar, 31 minus x bar, all this again. Then you make it square, this square. So you will have some values here. For 15 values you will have, then you add it, you will have summation xi minus x bar whole square, then divide by 15, then make it square root, and this is your sigma. So this is for ungrouped data, you are having the sigma for this over this. Now for group data, number b. So this b, it is group data, but here you see you are not having class intervals. It is written marks more than number of students. So marks more than means what? You see, above 0, more than 0, we are having 40 students. More than 10, 37 students gets marks more than 10. So what we need here, you write class interval. You write class interval here, class interval. So class interval, and this is right corresponding frequency. Then more than 0 is 40, more than 10 it is 37. So you make this class 0 to 10, and 0 to 10 you will have 40 minus 37, 3 students. Then in between 10, so more than 10, 37, more than 20, 32. So in between 10 and 20, in between 10 and 20 you will have 5 students. 37 minus 32. Next is in between 20 and 30 you will have 32 minus 27, it is again 5. In between 30 and 40 you will have 27 minus 17, it is 10. Then 40 to 50, more than 40, less than 50, it is 17 minus 7, 10, it is 7. Then 50 to 60, 10 minus 7, it is 3. 60 to 70, 7 minus 3, it is 4. 70 to 80, 3 minus 0, it is 3. And above 0 there is no value. So what you are having, so this is class interval, this is F5. So this is our frequency distribution table. So this is actually the given data, it is cumulative frequency distribution table. These are cumulative frequencies, these are lower limit of the class, and from this we are deriving this ordinary frequency distribution table. And we need ordinary frequency distribution table, means class interval and frequency, to find standard deviation. Now we need to find the so we need now xi. So xi, this is xi. So xi is mid value, so 0 plus 10, so mid value is 5. 10 to 20, it is mid value is 15. So xi's are this 5, 15, 25, 35, 45, 55, 65, 75. So these are x. Now see, our formula is, so we can use this formula, try this formula, this one, step deviation method. So consider one mean A. So capital A is there. So capital A you consider from the values in between 5 and 75. So suppose so we consider A as 35. Now we write di is xi minus a. So 5 minus 35, it is minus 30. 15 minus 35, it is minus 20. 25 minus 35, it is minus 10. Then 0, 10, 20, 30, 40. Then we require ui. Let us erase these things. We will erase this one. This is for ungrouped data. So di you are having, then ui. So length of class interval is 0 to 10. There are 10 observations. So divide di by 10. So we are having the values minus 30 by 10, it is minus 3, then minus 2, minus 1, 0, 1, 2, 3, 4. Then our formula is fi ui. So fi ui. So fi 3 into minus 3, fi 3 into minus 3 is minus 9. Then 5 into minus 2, it is minus 10. Then 5 into minus 1, it is minus 5. 10 into 0, it is 0. 7 into 1, it is 7. 3 into 2, it is 6. 4 into 3 it is 12, 3 into 4 it is 12. Now summation fi ui, and another we need, so this formula we are using, summation fi ui and summation fi ui square. So see this formula. So fi ui, one we need fi ui, other we need fi ui square. Now we make another column fi ui square. The fi ui square. So fi ui into u again. So it is 9 in minus 9 into minus 3 it is 27. Minus 10 into minus 2 it is 20. Minus 5 into minus 1 it is 5, 0. And 7 into 1 it is 7. 2 into 6 it is 12. 3 into 12 it is 36. And 4 into 12 it is 48. So we need now summation fi ui and summation fi ui square. So this sum is, this is 16 plus 7 to 16 plus 7 23, 28, 35. So unit place is 35, 5, then 3 comes out. 7 plus 4 11, 11 plus 4 15. So this is 1 5, this 1 5. And summation fi ui, it is 24 plus 6 is 37. This is positive, and 37 this is negative. It is 37, then it is 14. 14 plus 10 24. So 37 minus 24 it is 37 minus 24 it is 13. So we are having this summation fi ui, and this is summation fi ui square. Now put the values, and we need summation fi also. So summation fi is 40. You add all this, we will have 40. 40 means this is actually summation fi. So capital N is 40. Now put the value. Now sigma is, now you write sigma is equal to, h is 10 into root over summation fi ui square means 155 divided by n is 40 minus summation fi ui, it is 13 by 40 whole square. In calculator you find the values. So it is equal to 10 into denominator is 40, numerator is 155 into 40, 155 into 40 minus 169. Compute the value, use calculator, and you will have it. So this is the way of finding standard deviation. So this is number B, it is marked more than, and here you see marks less than. So when we have here you see marks less than, so this is also cumulative frequency distribution table. More than, this is less than, and these are cumulative frequency. We converted this to ordinary frequency distribution table having columns, class interval, then frequencies. So here also we need to make class interval. So class interval and then frequency. So class interval less than, so less than 10 it is 5, less than 0 is not given, so you make 0 to 10. Then less than 20, less than 10 is 5, less than 20 is 8, so in between 10 and 20 it is 8 minus 5, it is 3. Then in between 20 and 30 your frequency is 12 minus 8, it is 4. In between 30 and 40, 17 minus 12, it is 5. In between 40 and 50, 25 minus 17, it is 8. In between 50 and 60, 37 minus 25, it is 12. In between 60 and 70, 43 minus 37, it is 6. In between 70 and 80, it is 50 minus 43, it is 7. In between 80 and 90, 57 minus 50, it is 7. And in between 90 and 100, 60 minus 57, it is 3. So these are class interval and these are frequencies. So this is our ordinary frequency distribution table. Then we need xi. So xi is mid value of classes. So xi is 0 plus 10 divided by 2, it is 5, then 15, then 25, 35, 45, 55, 65, 75, 85, 95. So these are xi. And we need this formula. So these are fi xi. So previous one we use this one. This time we can use this one also, or this one also. Actually this simplifies the calculation. That is why it is better to use this formula when values are large. So assume mean 1 you take, say a is equal to, say a you can consider as, say a is equal to, here you can consider, say here, say a is equal to, say in between 5 to 95 we can consider 55. Now x minus a, it is d. So d so d are xi minus, so suppose this is di. So xi minus a, so 5 minus 55, it is minus 55, minus 50, then minus 40, minus 30, minus 20, minus 10, 0, 10, 20, 30, 40. Then ui you can write here ui di by, so minus 50 by 10, it is minus 5. So minus 5, minus 4, minus 3, minus 2, minus 1, 0, মই অকণ পিছত ফোন কৰিছোঁ তোমাক হা হ'ব and it is -1, then it is 0 and 1 2 3 4, and in a similar way you find fi ui, same procedure here, fi ui, then ui, and then you make the sum. Here our n is summation fi, it is 60, and we will have the standard deviation for this. So this is the way to find standard deviation of a data. Next it is variance. Variance is same. Variance is nothing but sigma square. You find sigma, then sigma square is variance. Sigma square is variance. Sigma means it is standard deviation, and so this is small data. We can try this one. 7a. 7a will try. So xi, so these are xi, then x bar you see, x bar is summation xi, you add it, this is 19 plus 3 22, then 24 34 30 39 49 59 59 66 66, then 74 74 plus 74 76 86. So it is total is 86 divided by 5 is 10 values, 10 observations are there, so it is 8.6. you write approximately 9. Then we write x bar minus xi minus 9 x bar. So our values are 4 minus 9, it is minus 4 minus 9, it is minus 5, then 6 minus 9 is minus 3, then 2 minus 9 is minus 7, then 8 minus 9 is minus 1, then 7 minus 9 is minus 2, 10 minus 9 it is 1, then 15 minus 9 it is 6, then 12 minus 9 is 3, 3 minus 9 is minus 6, and 19 minus 9 it is 10. Then xi minus 9 whole square. So it is minus 5 square, it is 25, then 9, then 49, then 1, 4, 1, 36, 9, 36, 100, 100. Then this is our summation xi minus x bar. So sigma square is summation xi minus x bar whole square divided by n. N is 10, and this is equal to, you add this, what you will have, this is 34 34 35 35 plus 9 44 44 84 84 88 89 90 125 125 then 9 125 plus 15 140 170, 270. This sum is 270. You check it. It is 270 by 10. So this is equal to 27. So this is our sigma square. This is the procedure of finding variance. Then coefficient of variation. So coefficient of variation formula is sigma by m into 100. Find sigma, then mean, and then find this. So these are the examples for this. And this example is scores given below. So more consistent. More consistent means you compare the, so for these are the values. So you will have different values here. So you find sigma for this data, mean for this data, then you will have sigma by x bar into 100. Again, for B, you will have another sigma, another x bar, and another sigma by x bar into 100. Now compare this. So which is less? So less coefficient of variation. So less coefficient of variation is more consistent. So you compare this. So this may be less, this may be less. So which one is less? You see it, and less coefficient of variation is more. If A is having less coefficient, then it is team A is more consistent, otherwise team B is more consistent. So this is the procedure of this. Then now come to correlation. So correlation you see, increase or decrease in one variable corresponds to increase and decrease in other variable. So two variables are there. So one is x, other is y. So when x varies, if x increases, then y increases. Then we see it is positive correlation. So if x increases means y increases. So we have an upward trend here. And if x increases, y decreases. So here x is more, but y is less. Here x is less, y is more. So it is a downward trend. So we say it is negative correlation. So this is positive, negative. If we can find any trend, then it is, we cannot say that there is some correlation. Then mathematically, this is scatter diagram. We just plot the points, plot the coordinates, and we have some trend. But mathematically, we have two variables, one is x, other is y, and we use this formula, x minus x bar, y minus y bar, then multiply them, square them, use this formula, and we have the r. Here there is no frequency distribution table, only some values, only these values, like these values, x, y. So x, y, so these are all ungrouped data. Variable x takes these values, variable y takes these values. So use it. So we need x bar, we need y bar, mean of these values, mean of these values. So we computed x bar as 68, y bar as 68, same value we got. Then we make this column, this columns we need, x minus x bar into y minus y bar, then square, we need to sum all this and then put here, and this gives us the value correlation. So this is negative correlation, means when x increases, we have y increases, y decreases. So that is negative correlation. And like this example, Like this example, we need to solve this one.